We had this really cool idea. I had this really cool idea with graphs, using the book, using awesome color-coded images. Internet is gone. So there's no internet for this video. We're going to record it anyway. All right. So if I have a quadratic, okay, let's say I have some sort of quadratic equation. This is maybe what it looks like. Could go the other way. Who knows what it's going to look like. There's a couple of terms that we talk about when we deal with quadratics. First term is the vertex. The vertex is that maximum or minimum point. And it is a point. A lot of times we'll call it h comma k. There are other ways of calling it as well. But the important thing is that the vertex is at either the top or the bottom of the parabola, depending on whether it's opening up or down. Okay. Another thing we really like talking about is this line right here. Notice that this quadratic is the same to the right of the line. It is to the left of the line. It's symmetric about this line. We call that the axis of symmetry. All right. And a lot of times I'm going to abbreviate that AOS. And again, the axis of symmetry is always written in the form x is equal to some number, because it's a vertical line. This is the formula for vertical lines. And these H's, by the way, these are not a coincidence that these are the same letters, because notice that the axis of symmetry is at the same x coordinate as the vertex. All right. Then we may also talk about x-intercepts, otherwise known as zeros, over here too. We also care about y-intercepts. Oops, that's supposed to be a t. Okay, so here are some of the things that we're talking about here. And there's a great color-coded, beautiful-looking graph in the online textbook. Emphasis on online. Okay, so this is sort of what we're going to start with. We're going to look at some graphs, find the vertex, axis of symmetry, the zeros, the y-intercept, talk about it. And we're going to, I want you to look for a pattern. You do example 1. Look for a pattern for the vertex. All right. So example 1, find the vertex, axis of symmetry, zeros, and y-intercept of the following. All right. And originally I was going to show this to you on Desmos, but Desmos again is already completely out of the picture. So you get to see my beautiful hand-drawn graphs myself. So this first one, go 5 in every direction. And I'm going to give you a graph that should look like this. And then as the point 2, comma that, and that, comma that, and oops. And it goes really steep after that. It's a very steep graph. Right? So the vertex is always that maximum or minimum point. That's going to be this guy right here. Because believe it or not, no matter what your eyes may tell you about the shape of this graph, this is the minimum, that point right there. That's the point 1, comma 1. We also need to find the axis of symmetry. Remember, this is a line. The axis of symmetry is this vertical line right here, because the function is symmetric on both sides. And again, that's always going to be the same x coordinate as in your vertex, but this is the equation of a line. It always needs to be written x equals something. Okay. What else are we asked? Zeros. Zeros. What are zeros? Zeros, remember, are the x-intercepts. Where does this function intersect the x-axis? Well, the x-axis is down here. Where does this function cross? Nowhere. No zeros. I always want to put an S there. If we actually solve the quadratic equation here, we'd get complex solutions. There are no real solutions. This never intersects with our x-axis. But it does intersect with our y-axis. The y-intercept going to be this point right here where it crosses the y-axis. That's the point 0, comma 3. All right. And I said, look for patterns about the vertex and the zeros. I don't think I said the zeros, but look for patterns around the vertex and the zeros. Well, there's no pattern. We only have one example. Okay. This has a vertex and there's no zeros, whatever. Okay, let's look at the next one. Part B is going to be this function over here. Let's go 3 in every direction. This time I actually looked at the function before deciding how much to go in every direction. So this function is down here a little bit. And then opens up like this. Kind of like so. Kind of looks like a little face, a nice weird wrinkly face. Anyway, vertex. Vertex is the maximum or the minimum. That's the point 0, -2. Like so. Axis of symmetry is, oh, the axis of symmetry is the y-axis. That's the line x equals 0. Remember, this is a special case. We talked about this in transformations. If something is symmetric about the y-axis, that means it's an even function. This is an even function right here. This was not an even function because it's not symmetric about the y-axis. It's symmetric about something. It's always going to be symmetric about the axis of symmetry. But if the axis of symmetry is the y-axis, then it's also an even function. So remember that even and odd functions will also be on your exam. Okay. So the zeros here, x-intercepts, same thing. Zeros are going to be when x is equal to -2 and +2. And finally, the y-intercept going to be where it intersects the y-axis, which is going to be 0, -2. That point. All right, so let's see. What's the relationship between the vertex and the zeros? The vertex is at the point 0, -2. I don't know the pattern. I don't know the pattern. We need more information. There's a pattern. Look at part C. I also lied to you. I do know the pattern, but I don't want to spoil it for you. Okay. Part C. Let's look at this function over here. Let's go 1, 2, 3, 4, 5 in every direction. Except for up, because I have no room. So we'll go 4. And let's look at a point over here. And it goes like this. And let's pretend it crosses through that point. There we go. Totally goes through the point. We got it good. All right, let's find the vertex. Vertex is the top or the bottom. That's the point. X is 2, Y is 3, 2, 3. Axis of symmetry. Again, I don't even need to look. As soon as I know the vertex, I already know the axis of symmetry. Always the same x coordinate. X is equal to 2. That's our axis of symmetry right there. The zeros are -1 and +5. And the y-intercept is, oh, I forgot to be very clear about that. The y-intercept is +1, 0, 1. So let's talk about this pattern. I said there's a pattern. Let's find it. Okay. Over here. The vertex and axis of symmetry. Axis of symmetry is at 0. That's in the middle of the zeros. Here, the axis of symmetry is at 2. 2 is in the middle of here. And graphically, right, this should make sense as well. Right? The axis of symmetry is always smack dab in the middle of the zeros. It has to be. Since it's in the middle of anything, either side. It's symmetric. Okay? So how do we find the zeros? Right? If we had a function, remember that the zeros are found when x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. This is how we find the zeros, x-intercepts, solutions to the quadratic equation. So what's in the middle of these 2 points? Because remember, this is something plus something and something minus something. So the thing in the middle is just this. Okay. The axis of symmetry occurs. Whoa, those don't look like different things. Occurs at the midpoint of these two zeros. And I could show you with the midpoint formula where the midpoint is. I'll just tell you. It's going to be x is equal to negative b over 2a. So again, we're in this section. We're going to use this formula to find the axis of symmetry in the vertex. It's just the quadratic formula without the square root. Negative b over 2a. All right? Let's use it. Example 2. Determine, that 2 got cut off. Determine whether there's a max or a min. Find its value. And the axis of symmetry. Okay. Part A is going to be of x equal to 2x squared minus 4x plus 2. That's a side note. This is number 24 from your homework. So first off, whether there's a max or a min, we also have to find the value and the axis of symmetry. We have to find 3 things. To find the maximum or the minimum, we're going to look at what shape this parabola has. Right, this parabola goes up. Right? It has a positive coefficient of x squared. So that already tells us that there's going to be a minimum, not a maximum. Okay? This is going to be a minimum of, I don't know what the minimum is. Let's leave that blank for now. But remember, the vertex, which has the maximum or the minimum, is always at the same x-coordinate as the axis of symmetry. And we said we have a formula to find the axis of symmetry. So, axis of symmetry is going to be at negative b over 2a, which is negative negative 4, or positive 4, over 2 times 2, which is 1. This right here is the axis of symmetry. Right? Axis of symmetry is just x is equal to 1. All that's left is to find what that minimum value is. And remember, the minimum value always occurs at the vertex. We have to find what is the value at the vertex. We'll plug in the x-coordinate of the vertex into the function to find that minimum y value. You get 2 times 1 squared minus 4 times 1 plus 2. Plug that into a calculator, you're going to get 2 minus 4 plus 2 is 0. The minimum value is 0. All right. So we found that there's a minimum. We found the minimum value. We found the axis of symmetry. We found it all. These are what the question's asking. Do one more part B, and then call it a day. All right. Well, for the first video anyway, you still got 4 more after this. I still have 3 more after this because I'm doing them out of order. Part B, g of x equal to negative 2x squared minus 12x minus 24. We're going to do the same thing. Again, look at the leading coefficient. Negative. This is going to be a downwards parabola. Okay? So at the vertex, is that going to be a max or a minimum? It's going to be a maximum. That's the biggest it ever gets. There is no minimum here. It goes down and down forever. But there is a max value of this parabola. We're going to say the max of, I don't know the max value yet. Let's leave it blank. But the vertex tells us that maximum value. We also need to find the axis of symmetry, which is always negative b over 2a. Again, in this case, negative 12 is positive 12 over 2 times a, which is negative 2. It's 12 over negative 4, which is negative 3. Our axis of symmetry is that answer, x equals negative 3. That's part of our answer. To find the maximum value, that's going to occur when we plug in this x equals negative 3 and get the y value here. The y value on the axis of symmetry is always that vertex coordinate. That's your max and your min. So we're going to find g of negative 3. That's going to be negative 2 times negative 3 squared minus 12 times negative 3 minus 24. I can't do this one in my head. This is negative 2 times negative 3 squared is positive 9. This becomes a plus 36 minus 24. Becomes a negative 18. These two combine to be a plus 12. We get negative 6. This is the y value at the vertex. That's going to be that maximum value. The biggest this function ever gets, negative 6. You can check your answers to these on a graphing calculator or on Desmos. I would show you this if I could, but I can't, so I will not. But you could check your answers. The biggest y value we ever get is negative 6. The axis symmetry set x equals negative 3. All right, go enjoy those problems.